Design principles are fundamental guidelines that inform and shape the structure and behavior of software systems. These principles help developers and architects create software that is maintainable, scalable, and adaptable to change. By adhering to design principles, software can be more understandable, flexible, and robust, reducing the risk of errors and making it easier to extend or modify. Some of the key design principles that we are going to talk about in this particular video include solid principles, which emphasize creating software that is well organized and easy to maintain. Next, we're going to look at KISS, which is keep it simple, stupid, which encourages simplicity in design to avoid unnecessary complexity. Next, we're going to look at GRASP, which is General Responsibility Assignment Software Patterns, which provides patterns for assigning responsibilities in object-oriented design. Next, we look at YAGNI, which is You Aren't Gonna Need It, which advises against implementing features until they are actually needed. Finally, we're going to look at DRY, which is Don't Repeat Yourself, which focuses on reducing duplication in code to ensure consistency and maintainability. Together, these principles serve as a foundation for building high quality software that meets both current and future requirements. Solid is a set of 5 design principles intended to make software designs more understandable, flexible, and maintainable. S stands for Single Responsibility Principle. A class should have only one reason to change, meaning it should have only one job or responsibility. O stands for Open Closed Principle, OCP. Software entities, classes, modules, functions, etc. should be open for extension but closed for modification. L stands for Liskov Substitution Principle, or LSP. Objects of a superclass should be replaceable with objects of a subclass without affecting the correctness of the program. I stands for Interface Segregation Principle, or ISP. No client should be forced to depend on methods it does not use. This means creating specific interfaces instead of single general purpose interface. D stands for Dependency Inversion Principle, or DIP. High level modules should not depend on low level modules. Both should depend on abstractions, example interfaces. Abstractions should not depend on details. Details should depend on abstractions. Here is an example in Java code where we have a class user a class called as user with private string name. The user related properties and methods can be defined here. Then we have a user service which has a public void save user method inside it. Logic to save the user to database will be returned here. One of the examples of OCP is here where I have a shape interface where I have created a function double area, then a class circle here which implements the shape which is the above interface and kind of defines the double area method in here. We also have the square class which implements shape again and has the double area function implemented here. Same for next we have the class area calculator which has the double calculate area function inside here which takes the shape function and returns shape.area depending on which shape it is. KISS, keep it simple stupid. The KISS principle states that simplicity should be a key goal in design and unnecessary complexity should be avoided. When some of the key points include the simplicity, which says keep designs and code as simple as possible. Next key point is avoid over engineering. I mean, do not add functionality unless it is absolutely necessary. Next one is ease of understanding. The simpler the code, the easier it is to read, understand, and maintain. So here is an example for case which is written in Python where I have a calculate area function which takes shape and dimensions as parameters, where I check if shape equal to circle, return this, if shape equal to square, return this, or return none. Now simple and clear code here where I am writing a kind of using whatever we wrote above into two different functions: calculate circle area which is called, and calculate square area which is called by calling that function. So instead of making it more complex, you can create simple functions and call them directly. GRASP, General Responsibility Assignment Software Pattern. Now GRASP is a set of principles for assigning responsibilities to classes and objects in object-oriented design. The patterns it has is, first one is information expert, assign responsibility to the class that has the necessary information to fulfill it. The creator pattern, where assign responsibilities to create an instance of a class to the class that aggregates, contains, or closely uses the created object. Next pattern is controller, which assigns the responsibility of handling system events to a controller class. Low coupling pattern aims to reduce the dependencies between classes to make the system more modular and easier to maintain. We have the high cohesion pattern, which keep the related behaviors and data together in a class to make the system more understandable and maintainable. We also have polymorphism pattern, where assign responsibilities based on dynamic or runtime types. We have pure fabrication pattern, which talks about assigning responsibilities to classes that do not represent a concept in the problem domain but are created to achieve a design goal such as improving cohesion or reducing coupling. Indirection pattern assign responsibilities to an intermediary object to decouple interaction between components. We have finally protected variations pattern, which says protect elements from variations in other elements by wrapping the unstable elements with stable interfaces. Here is an example. Look at the information expert example here, where we have a class order which takes an element private list items with a function of calculate total, which returns back double, where initially is set to 0, and then for each item we iterate through that and increment the price for that particular item and return the total. There is also an creator example where we have a customer class which has a function create order which returns back order, where it will return back the order. YAGNI, you aren't gonna need it. YAGNI is a principle of extreme programming that states you should not add functionality until it is necessary. Now, key points are avoid premature optimization, do not implement features until they are required. Next is focus on current requirements, implement only the functionalities needed for the current situation. Here is an example where you're adding unnecessary features, like we have the calculate area where it takes shape, dimensions, color, filled equal to true. Now if shape equal to circle, it will return back the area for that. Shape equal to square, it will return the area. Now why do we need color and filled properties for this? We don't need those. So we are adding unnecessary features inside this particular function. Now keeping it simple, in the next here we just return back, we take the radius for the circle and then return back the area. We take the side for the square and return back the area. So keep it simple. Dry or don't repeat yourself. The dry principle emphasizes the reduction of duplication in software design, meaning that every piece of knowledge must have a single, unambiguous, authoritative representation within a system. Key points include avoid duplication, prevent code duplication to ensure maintainability. We have single source of truth, where you ensure that any piece of information or logic exists in only one place in the code base. Easier maintenance, which says changes need to be made in only one place. Now here is an example for dry, where we have some duplicate code where I'm calculating the radius, calculating the cylinder volume, which takes the radius and height. Now with dry code, what you do is you calculate the area, pass the radius, but when you are doing the cylinder volume, you pass the radius and height, but then you call the circle, call the calculate area inside here and pass the height, because you're doing the same thing twice in the duplicate code, whereas you can call the existing function. So next time when you change something, if you have to change something, you can change it at one place and not multiple places. Now each of these principles guides software development towards more maintainable, flexible and understandable code. By adhering to these principles, you can create systems that are easier to modify, extend and understand. If you have any questions on this particular section, let me know in the comments and I'll get back to you.